Okay, for example 3 of row integration by parts, let's take a look at the integral of e to the 3x times sine of 2x. RIP, or row integration by parts, is the tabular method for integration by parts with an emphasis on the rows. Each row represents an integral, and we proceed one row at a time. So if you haven't already seen an introduction to RIP, I suggest you pause this video, take a look at the intro video, which comes with a couple of examples, and then get back to this one later. Alright, with row integration by parts, we always start with 4 columns, alternating plus minus signs, functions to be differentiated, functions to be integrated, and a last column to represent the integral of the product of a given row, and that's where we get row integration by parts. So we always start with a plus sign indicating a positive 1. I'm going to pick sine of 2x to be differentiated, not that it matters in this example, and I'm going to have e to the 3x left to be integrated. Now notice that the product of 1 times sine of 2x times e to the 3x gives me the original integrand. In other words, the top row represents the original integral, and I don't even need to put that down here in the 4th column. First iteration of row integration by parts, we alternate plus minus signs, differentiate sine of 2x, integrate e to the 3x, and take the product of what we get. So negative 1 times 2 cosine 2x times e to the 3x over 3. The integral of that, well, what does that give us? Is it anything better? Is it worse than what we started with? Well, actually, it's about the same, right? Because the cosine here and the sine in the original integral are about the same level of difficulty. This negative 2/3 isn't really changing anything in terms of difficulty of dealing with this integral. So should we stop? Well, probably not yet. So let's keep going and see what more iterations of integration by parts will give us. Okay, so alternate plus minus sign, we get a plus sign, differentiate 2 cosine 2x, integrate e to the 3x over 3, and take the product of what we get. Okay, so 1 times negative 4 sine 2x times e to the 3x over 9, and integrate that. Negative 4/9, the integral of e to the 3x sine 2x. Does that look familiar? Hopefully it does, because of course it's a copy of the original integral. So whatever that means, we should stop and see what we have, right? We have a copy of the original. So what does that mean? 2 iterations of row integration by parts yield a copy of the original integral. So let's see how we could get the antiderivative that we're looking for out of this situation. All right, so now at this point we should pull what we have out of the table and make it into the formula for integration by parts. So we take the original integral, and the first term is going to be a 1 times sine 2x, go down a row to pick up e to the 3x over 3. The next term is negative 1 times 2 cosine 2x, go down a row, pick up e to the 3x over 9. Gives us the second term. The last term is given by the integral from the last row. In other words, take the product again of all the terms in the last row, integrate it, and that represents the last integral from integration by parts. So we almost have the solution, but there's some algebra left to do, right? We got to basically take this new integral that we got, that's copy the original, add it to both sides of the equation, and solve for the original. So in other words, let's rewrite this a little bit, because it could be a bit messy. Let's replace the original integral with an a, the first function in the antiderivative with a b, but keep the 1/3 separate. Similarly, let's keep it as negative 2/9 times a function d, which would be e to the 3x cosine 2x, minus 4/9 of a, because it is a copy of the original integral, plus a constant. So now it's just algebra. We just have to add a to both sides, and we get 13 over 9a is a third b minus 2/9 d plus a constant. Multiply both sides by 9 over 13, and we get a is equal to 3/13 b minus 2/13 d plus a new constant c naught, which is basically the old c times 9 over 13. So we just had to translate this back into the functions, and that gives us the original integral, which is equal to a, is given by 3/13 times e to the 3x times sine 2x, which is the b function, minus 2/13 of the d function, which is e to the 3x times cosine 2x, plus a constant. So there we go. Please subscribe, check out the playlist, and learn to master integration by parts.